Hello, welcome back. We're about to wrap up chapter 9 already, really. And we're going to talk about weights and temperatures this time. Pretty much, although there are different quantities, most of the skills you've already picked up from section 1 and section 2 will be very closely applicable to working with weights and temperatures. So a couple of things we're going to look at is, first of all, I have to look and make sure my pen's working. So, okay, it's working. First of all, we're going to work with metric prefixes again. Same prefixes we had before, except we're going to work with weight this time. Basic unit being a gram. We're going to take those units of weight and convert them from one to the other. You can use your unit fractions, or you can move the decimal point according to where you're moving within the metric system. Hopefully that will make sense once we're finished here. You can go back and go through it and say to yourself, oh yeah, of course, that makes sense. There's a relationship between volume and weight, and just a hint here, the basic connection is water. And it's water because, well, we have lots of water on the planet. We're going to use dimensional analysis like we did before to change to and from the metric system. Use that unit fraction. And last of all, a bit about the temperature scales. Not a whole lot. There are 2 or 3 formulas, actually 4 I think, and just make sure you add all these things to your toolbox, so to speak, for the metric system and for units in general. So let's go to weight and mass. First of all, weight. It's a measure of the gravitational pull on an object. For example, your weight is a measure of how much gravitational pull there is on your body. Mass is close in a way, although it's also different too. If you've taken physics, you know there's a difference between the two, and it's a little bit subtle. But we won't have to worry about that. We're considering the two as just about the same thing. Mass has to do how much matter there is in an object, how much stuff there is in it. And that's determined by the molecules in it, the atoms in it, and so on. So we're going to talk about mass and weight as equivalent, which means when we're talking about grams, we can be talking about mass, or we can be talking about weight, just to keep it simple. Here are a couple of conversions that you want to keep in mind if you don't already know those. 16 ounces make up a pound, 2,000 pounds in a ton. Notice in particular here that in the English system it's a capital T for ton, because in the metric system it's also a ton, although it's a little bit different, and they use a small t for that. Now notice this is a ton. In the metric system it's T-O-N-N-E, still pronounced ton, and they just use a small t for the metric ton unit. So here again are the prefixes for the weights, the same as we had before. The only thing that's different is the actual unit that we're working with. Going up this way, these units are bigger by multitudes of 10 times 10 times 10. And you can see this is 10 grams, 100 grams, 1,000 grams. And to be honest, kilograms, yes, you need to know that. In fact, you probably run into kilograms even in the US quite often. Hectograms, probably not. Decagrams, probably not. Grams, yes. If you look on most packages, you can see it tells you how many grams, as well as ounces or whatever else they have it in. Decigrams, not too often. Centigrams, again, not too often. Milligrams, yes, especially in medicine. So how do you convert? One of those ways of doing it is just by moving the decimal point. Notice we're going here from milligrams to grams. So if we sneak back here and take a look, milligrams are down here, grams are there. Notice that to get from one to the other, you have to make 3 bounces, let's say, or 3 steps. That'll also mean 3 decimal points. So if we want to change milligrams to grams, we're going to move this decimal point right here 3 places. Now, here it says multiply by 10 for each step to the right. Well, you're here, you're here, and you're moving there. So if we need to move to the left, we're going to divide by 10 3 times. 1, 2, 3. That means you're going to move the decimal point over here to change it to grams. And that'll get rid of the milli part, and you'll have the number of grams. So it looks like this. You're moving from milligrams, 1 step, 2 step, till you finally get to grams. If you're moving to the left, you're going to move the decimal point 3 places to the left, and you get your new magnitude for the new unit. You can also do the same thing by taking that unit. We've got 950 milligrams. We can use the unit fraction again. We want to get rid of the milligrams, end up with grams. Fine. Now, which one of these is bigger? You can sneak back to the last one. You can see milligrams represent 1,000th of a gram. So this is bigger. So you put a 1 there because it's bigger. And to make these two equal, this small unit here, the milligrams, you have to have a lot of those to make up a gram. And there's your conversion. We can cancel out the milligrams, we end up with grams. We have exactly what we want. And using our calculator or doing it manually, you get the proper unit just as we did down here. Okay, here's some more. Now this puts volume and weight together. And notice we're talking about water, as I mentioned earlier. 1 cubic centimeter, and sometimes you'll hear this referred to as cc's or CU/cm for cubic centimeters. Remember one big thing from here. This is the biggest one. Cubic centimeters and milliliters are the same thing, and in weight it's equal to exactly 1 gram. So it's nice and clean, easy to remember. Those 3, you'll see them quite often. In fact, if you have a medicine bottle, for example, I'm not good at drawing, you can tell from that it looks more like a heart. But if this were a medicine bottle, you'd see something on it that had it in milligrams or milliliters, or it might be in cubic centimeters, or it could be in grams. All 3 of those ways are something you might see for medicine. The second one, you probably won't see this too often. A cubic decimeter is 1,000 cubic centimeters, and you're back up here. At 1,000 cubic centimeters, this is a good one to remember. Cubic centimeters, 1 liter. And just as smoothly, the weight is 1 kilogram, 1 nice equal kilogram. Now this third one you probably won't use practically too much. 1 cubic meter, which would be huge, that's a little bit more than a cubic yard, and that's big. You get concrete in those units. But anyway, 1 cubic meter is the same as 1 kiloliter, 1,000 liters. There's your 1,000 kilograms because liters and kilograms go together. And that 1,000 kilograms is 1 ton. And that's TONNE, or a metric ton. And if you check the conversions, you can find out that 1 ton, our ton, is 2,000 pounds. 1 ton, metric ton, is roughly 2,200 pounds. Just to give you an idea of how those work out. Okay, let's do a short conversion here. We're going to take our aquarium that has a 25 hundredths of a cubic meter. How much does it weigh? You better know that, because if you're going to put it on some kind of a box or some kind of a dresser or something, you better know whether it's the dresser or whatever it is, it can hold it up. So we're going to use our unit fraction, because from that table we saw just a moment ago, 1,000 grams and 1 cubic meter are equivalents when we're talking about water, and we are talking about water. So we can use our unit fraction right here. Notice we started with cubic meters, so we want cubic meters down here, and that means the kilograms goes up there. And just a little bit of arithmetic, and you've got how much that water weighs. 250 kilograms, excuse me. So here's some conversions between English and metric. And these are approximate, they're not exactly, but they're close enough for our purposes. 1 ounce, 28 grams. 1 pound, 0.45 kilograms. And if you reverse that, 1 kilogram, as I mentioned earlier, is about 2.2 kilograms. 2.2. If you reverse that, divide both sides by 2.2, you get that 0.45, just in case you want to. And 1 ton is equal to 9/10 of a metric ton. Remember, the metric ton is TONNE, and it's a small t for metric ton, as opposed to a big T for English ton. Not quite the same, in the same order of magnitude though. So let's change pounds to kilograms. Well, unit fraction to the rescue. So here's our unit fraction. We put the pounds in the bottom because we're going from pounds, so we want to cancel out the pounds. So here's our start. Here's our unit fraction. The pounds will cancel. A little bit of calculator work. And there's our answer. 72 kilograms is about the same as 160 pounds. Now, we're going to talk about temperature for a few minutes. These are good for you to remember. Some of you will end up at some point going to another country. It's good to know when you look at a temperature gauge or you hear something on the television. If you hear it in Celsius, you know what it corresponds to in the English scale or the Fahrenheit scale. You should be familiar with the 32 at freezing, the 212 for boiling. In Celsius, suppose you're in France on a visit. Water freezes at 0. That's convenient, right? And it boils at 100. Pretty easy to remember. And the conversions aren't too bad, but you want to write these down. It's easy to get them backwards, but if you have them written down, you're in good shape. If you are given the Celsius and you want to find the Fahrenheit, just use this formula. And you can use either 9/5 or 1.8. They're exactly the same. and you can get your Fahrenheit temperature from a Celsius. Going in the other direction, if you have Fahrenheit and you want the Celsius, easy. Just take the Fahrenheit, subtract 32, multiply by 5/9, bingo, you've got your Celsius temperature. Now, here's a little scenario, a little bit scary perhaps, but not too badly. Remember, this isn't really you. You're on your European vacation and you go downstairs and you ask the people, I don't feel exactly right. Can I borrow a thermometer? So you clean the thermometer, take your temperature, it says 37 degrees Celsius. Is that scary? Should I be taking some ibuprofen or something? Let's check it out. We want to go from Celsius to Fahrenheit. So we need the formula that says Fahrenheit equals. And you can go back there and check which one of those you want to use. There's the formula. Put the 37 in where the C is and do a little bit of calculation. 98.6. It sounds like you're perfectly fine. No panic necessary. Next, warm spring day, 77 degrees. Lots of us will enjoy that when it comes back. Of course, in South Carolina, it comes back a little bit earlier, sometimes even in February. Well, what is it in Celsius? So if you were leaving here and you're going to Italy, for example, and they said it's pretty comfortable over here, and you're wondering what it is compared to the 77 degrees in Spartanburg. So, find the equivalent temperature. C equals, you can get that formula. Put the 77 in where the F is. 77 goes where the F is. Just do a little bit of calculation. And it's 25 degrees Celsius. That's a good 77 degree warm spring day. So those are equivalent. So if in Spartanburg it's 77 degrees and you call someone in a country that uses the metric system and they say, oh, it's 25 here, you'll instantly know that's a good, comfortable temperature. It won't be real hot, it won't be real cold, and if you were going there the same day on a jet or something, it'd feel the same. Now, last of all, the Kelvin temperature scale. Usually this is used for scientific things, but there are a few things you might find handy. So just put this in your paper notes. 0 degrees is this in Celsius, and it's called absolute zero. Absolute zero in the Kelvin temperature. What's the boiling point of water? 373.15. Now, one thing they left out, you might be curious, well, what about freezing? When will water freeze? Well, if you do a small bit of arithmetic, 273.15 degrees Kelvin is freezing. Because remember, 0 is very, very cold. And there are the conversion factors to go from Celsius to Kelvin. If you should happen to have Kelvin and you want to go to Fahrenheit, just change it to Celsius first, then back to Fahrenheit, and you're in business. You've got those formulas. And here's a small picture before we wrap it up. This shows you what they look like all put together. And there's the absolute zero in Fahrenheit, which we usually don't do because if we're talking about absolute zero, typically we're doing something scientific, so we would use either the Kelvin or the Celsius. Well, that's it. I hope that didn't raise your temperature too badly. And I hope you caught this and wrote down the essential formulas and got some good ideas. In the meantime, try those exercises and bring your questions to class. Until next time, I'll see you. Bye-bye.